All right, so if I could give you one piece of advice, it's to make sure that you bring a scientific calculator on that day. You will not be borrowing a scientific calculator from myself or from someone else. Okay? Yeah, you just can't be graphing. Like, so if it has the big screen. Yeah. And you don't want to forget it. So if you need to set a reminder in your phone or something to remind you on Tuesday to make sure it's in your bag, you want to do that. Okay? Well, set the reminder Tuesday or early morning Wednesday. Okay?
What day is the test?
Your test is Wednesday.
Is that the last day?
Yep. You will spend your last moments as a sophomore in this very room. Yep. Or freshman. All right, so chapter 7 was all the right triangle stuff. So this document is in the file folder, the same one that has the review in it. But I'm going to kind of just like highlight a couple of things. So that's why I said if you want to open it up as we go through the chapters and maybe make notes, I would probably advise that's a good thing to do. I'm not going to go through each and every one of these, but I'll go like kind of topic by topic on them. And then if you have a specific question, obviously, now would be a good time to ask. When you come back to see me next week, we'll do review activities. I'm not going to go question by question through the packet because hopefully by then you've familiarized yourself with the packet. Okay? All right, so in the beginning, obviously, it starts with Pythagorean theorem. So you just need to know a squared plus b squared equals c squared. That gets you through all of these. Okay? You're going to have a calculator. So if the numbers are bigger, the calculator is going to help you. The questions will either state to answer it with a rounded decimal, so you'll use your calculator to actually find the square root that's missing if it's not a whole number, or it will say simplified square root, and that way if it was something like square root 50, you would give it to me as 5 root 2. Okay, so it's pretty, and especially multiple choice, I mean it's either going to be in decimal or it's going to be in square root. 71 or 7.1, this section here is find the area of an isosceles triangle. So remember that isosceles, you would take that, when you have the altitude drawn to the bottom of the isosceles, what happens to that side? Good. So this would be like a 24 and a 24. And then you'd have to find the height. This is actually a triple. It's 7, 24, 25. But if you don't know it, Pythagorean theorem, get you that. You know all the triples, right? Ava's got all the triples. Okay. And then 1/2 base times height. So 1/2. 48 times 7, and that's where the 168 comes from. Easy stuff, right?
Are they going to be like that easy though?
Some of them, yeah. Yeah, there's a question just like that.
Choice question?
Yeah. No, 30 questions are multiple choice, 20 are open-ended. So your midterm was 70, and I think a lot of you said it was long. There's also proofs in there. Your final's 50. Yeah, it's only 50.
That's nice.
And then you've got surface area. Yeah, midterm was 70.
That's why no one used.
No one, but it was you struggled. You struggled definitely more than others.
Yes, I left like 10 blanks. Yeah, I remember that was hard.
Well, now it won't happen again. All right, 7.2 says to tell whether the given sides of a triangle can represent the right triangle. So in order for that to be true, it's the converse of the Pythagorean theorem. C squared would have to be equal to a squared plus b squared. If it doesn't, then it's not a right triangle. If it does, then it is. Okay? And C is the biggest one there. That's pretty much the only thing you would look at. And then the second part is it acute, right, or obtuse? So if it equals it, if C squared equals a squared plus b squared, then we know this is a right triangle. If C squared is greater than a squared plus b squared, it's obtuse. And if C squared is less than a squared plus b squared, then it's acute. And then the question comes, can it even be a triangle? And in order for that to be true, every two sides must be greater than the third side. So add the two smaller sides up, make sure it's bigger than the third side. So like this one says not a triangle because if I add 11 and 19, I get 30, and 30 is not bigger than 32. Alexis.
How do you know which numbers to put where?
For this part, you mean? You always put the biggest one where the C is. Good question. So biggest one always goes where the C is. And if it's a root and you're unsure, use your calculator, right? Do 5 root 26 and see if that's bigger than the other ones.
You just start with the biggest number.
Yep. Biggest numbers, they're C. Questions so far? Okay. Similarity statements. You don't have to worry about the similarity statements. So if you want to go through and start maybe like crossing through some stuff, we kept off a similarity but you will use it in 7.3. So there were two little ratios that you learned in this section, and they were segment 1 over altitude equals altitude over segment 2. Yeah. So the first grouping you don't, but this one too. And then the second one was hypotenuse over leg equals leg over segment of the hypotenuse adjacent to the leg. So if you look at like 22, the x is on one of the segments of the altitude, or one of the segments, sorry, segment of the hypotenuse adjacent to the leg. So like this would be 22. 22, you have a value on the altitude, nothing on the leg. So I would do segment 1, which could be 5, over the altitude, which is 5, equals the segment 2, which would be x, over the, altitude, not, switch that, altitude, which is 5, over segment 2, which is x. And then you cross multiply, divide. This one's easy, that's 5. But you would use that one for 22, and 23 is also, so that would be segment 1, or 1 over y would equal y over 4. And then cross multiply, and in that case you'd square root. You're going to cross multiply and divide, or cross multiply and square root. And then hypotenuse 1 would be for all the other ones. Well, not 25, that's this one. Segment of the hypotenuse adjacent to the leg. So if you look at 24, the hypotenuse is the hypotenuse of the big triangle. So the big triangle's hypotenuse would be x plus 3. Over the leg, we only know one leg, that's 5, equals the leg, which is 5, over the segment of the hypotenuse adjacent to the leg. So the part of the hypotenuse that's next to the 5 would be the 3. And then you'd cross multiply. And again, in a multiple choice format, you're either going to see it like that, or you're going to see it in decimal form where your answer would be 5.3. All right, 7.4 started your special right triangles. There's two special right triangles, 45, 45, 90, 30, 60, 90. So in my 36, let's start 45. 45, 45, 90 triangle, which would be an isosceles right triangle. The side lengths have the relationship of A, and A root 2. So for something like 28, it gives you this would be A, this would be A, this would be A root 2. So if it gives you that A is 7, then X is also 7, and Y would be 7 root 2. And let's look at 30. Okay, this time they give you, this would be your A, this would be your A, this would be your A root 2. This time you get that A root 2 is equal to 9 root 2. So if I divide both sides by root 2, I get A is 9. And that's going to be this side and this side. So both A and B would be 9. God bless you.
Thank you.
The other one is 30, 60, 90. So in a 30, 60, let's say this is 60, let's say this is 30. Opposite the 30 is A, opposite the 60 is A root 3, and opposite the 90 is 2A.
Say that again?
So opposite 30 is A, opposite 60 is A root 3, and opposite 90 is 2A. And again, this is one of those like pieces of information I would make sure to highlight so that you go back through and review it. And then obviously got to figure out how to apply it, right? So in 31, this would be A, this would be A root 3, and this would be 2A. So if 5 is A, then M is going to be 5 root 3, and N is going to be 10.
Going back to the
And we got to that special magical little word, Sohcahtoa. You sounded southern. Sohcahtoa.
Is that
That started 7-5, yep. And actually, remember, that's one of those things that's not in your book. It's in your notes, but it's not in your book. Like the word Sohcahtoa is not mentioned, which is super weird because it's this life-saving little word. Okay, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and the tangent would be opposite over adjacent. So this one actually says like find tangent of find. You're not going to have questions like that. Okay, so it won't be explicit find it and you're looking for it. It's something more like this where you're just solving the right triangle. Actually, I'm going to go straight to skip the directions for 7-5. These are good practice problems, but the wording is not going to be like that. It's not going to tell you use tangent, use sine, use cosine. It's going to be more like these on the bottom where it says solve it, and you have to figure out which one you have to use. Does that make sense? So with something like 46, if you're solving, like let's say that this is your x, you can use Pythagorean theorem there to find the missing side. But then to find an angle, and it doesn't matter which one, let's say that this is, I want to find angle D. First of all, use the ones they give you, right? Use the 5 and the 12 because you know those are right. In relationship to D, 5 and 12 are where? So this is going to be tangent. So the tangent of D would equal 5 over 12. And then in your scientific calculator, this is where you do the tangent -1. So when you're looking for the angle is when you hit that -1 button. And then that would give you 22.6.
Wait, when you're looking for the... Wait, when do you use the -1?
When you're looking for the angle.
So when do you use regular?
So if I wanted to find the missing side, like in 48. 48, I can't use Pythagorean theorem, right? I'm missing 2 sides.
Yeah.
So if I wanted to find, let's say this is C, again, I always pair it with the stuff they originally gave me because I know that's safe. So 25 they gave me here, 25 degrees, and 25 being the hypotenuse. And what I'm looking for is opposite, so this would be sine. So the sine of 25 degrees would equal C over 25, and then I'd multiply both sides by 25. And that's where you would get, so that's AB. That would be 10.6. And then I can use Pythagorean theorem to find the third side, or you can use the other. So if this is B, then I can say that this would be adjacent and hypotenuse, which would be cosine. Cosine of 25 equals B over 25, and then 25 times the cosine of 25 will give you B, or side AC, which is 22.7.
Wait, what is AB?
AB is just this side, like I labeled it, see, just to give it one letter, but AB is that side. So on these types of questions, it'll just put in, you'll get an X and a Y on a side or an angle, and it'll just ask you to find that one. You're also going to have word problems from here, so just make sure that you could do a word problem that is, sine, cosine, tangent. If you want extra practice problems for that, I would go back to 7-7, because that's where you're solving the right triangle word problems for. And I think there's worksheets on the iTunes U course for solving right triangles using the word problems, so make sure you use that stuff. Okay, then we got to 8, and 8 was all the polygons. So we started with interior angles of the polygon, so let's talk about first all those formulas. So interior, sum of the interior, no, that's exterior. Sum of interior is the one that changes, right? N minus 2 times 180. And then each interior, if it's a regular polygon, is N minus 2 times 180 over N. And then sum exterior is 360 no matter how many sides. And each exterior would be 360 divided by the number of sides. So for 1, for 2, for 3, and for 6, those are all interior angles. So you've got to find the sum by doing n minus 2 times 180, depending on how many sides there are, and then subtract from it what you have. And what will be left is what you're missing, right? So like if I did 3, this is 1, 2, 3, 4, 5, 6, 7 sides. I'd do 7 minus 2 times 180, 5 times 180, which is 900, and then from that I would subtract 90, 153, 149, 122, 115, and 154, and the 117 that's left would be the angle that's missing. So that's the same for 1, 2, 3, and 6, except that 6 has 2 x's. That's all.
On the test, are you gonna have a calculator?
The whole time. The whole time. Yep. So hopefully it'll make stuff like that neater. Yeah.
And the number of angles, right?
And the number of sides, which is the same. It's the same as the number of angles. Yeah, so then like something like number 4, right? You would just take all of these and subtract them from 360 and get left with what's left. Same thing here. So 360 minus this, oh, this is the interior. Yeah, so you would have to do, you could do it. This would be, yep, this would be a line down here, right? So 180 minus that 148 would give you the 32 that's on the outside. And then you've got all the angles minus, except for x. Subtract them from 360. Okay, so 88.1, measure of the interior and exterior. So you literally just take the sides. Obviously know your vocab, like know that hexagon is 6, know that heptagon is 7, octagon is 8. You need to review all that stuff. And then we get to parallelograms. So in 8.2, this started all the stuff you had to know about parallelograms. So remember parallelograms, which is that little symbol, opposite sides. Opposite sides, congruent. This I would go back to chapter 8's Quizlet and make sure you go through it because it's got all that stuff on it. Opposite angles, congruent, diagonals bisect each other. So something like 10 hopefully is easy, like this is equal to this, and then this is equal to this. Probably not going to get something that simple, okay? More likely something like 11, this would be equal to this, and then this would be equal to this. Set them equal to each other, solve. Oh, and consecutive angles are supplementary. I mean, I don't think it's going to be hard, and I took it in about half an hour maybe, so I figure at least double your time, triple your time, and you're still good. Yeah.
But you did them all right.
Wait, you said half an hour?
I didn't sit down and time myself. The properties of parallelograms. 8.3, you can cross through. There's no coordinate stuff. And then 8.3 is how you would prove a parallelogram, which is the converse of all that stuff. So if both pairs of sides are congruent, if both pairs of sides are parallel, if both pairs of opposite angles are congruent, if the diagonals bisect each other, and then there's the one added one, that's if the same pair, so just one, of opposite sides are congruent and parallel.
So it's all the same ones.
It's the converse to all of the ones we just listed, plus that one. So if opposite sides are congruent, if opposite angles are congruent, if opposite sides are parallel, if diagonals bisect each other, and then this one, if the same pair of opposite sides are congruent and parallel. No. Questions like that. Like, what do you know about, what's true about a parallelogram, what's not true about a parallelogram, which of the statements below is not true about a square, that kind of thing. So this is, remember that like Venn diagram that we like wrote out all the properties? This is definitely something you want to review. What do you know about, it's not, I don't think it's that tricky. It's not like, it's more of like a which of the following is not true or which of the following has to be true, that kind of a thing. It's not like you have to write out a proof or anything like that. Okay, but remember that you've got rhombus, square, rectangle, trapezoid, and kite. You want to know, obviously, the definitions of them. Okay, kite's the only one that doesn't have both pairs of sides parallel, right? Because if you had the little, actually, that's not true. Trapezoid, too. If you have your little box and you've got your parallelograms in here, then inside there would be then you'd break it down and you'd get, remember it was a square, or no, it was a rhombus, and it was a rectangle, and then if the rectangle and the rhombus had a baby, it'd be a square. Yeah, parallelogram breaks down into a rectangle and a rhombus, and then if those merge, it's a square. And then separate from that is a trapezoid, which has its own unique properties. It's got one pair of parallel sides. And then a kite, which is that like diamond shape looking thing. The kite has two pairs of congruent sides. No. Yeah. It's just, there's a lot of stuff within there, right?
That was hard.
Yeah.
There's a lot of stuff within there.
No, I got such a
Well, because you have to know, remember we had to like trickle down and then work back up. Like that, those were your always, sometimes, never. There's not always, sometimes, never questions. That's the good news.
Yeah.
Okay, it's a beautiful thing. Can you? So you need to know all those properties. Again, that's stuff that's on that's a Quizlet. That would be a good Quizlet to review. Okay, and then we got into, like, this is the mid segment of a trapezoid. The mid segment equals 1/2 base 1 plus base 2. That's not hard, but it is something you obviously need to memorize. So if I add 19 and 31 and divide by 2, I get 50, or 25, sorry. Same thing for 36, same thing for 37. Mid segment is 1/2 base 1 plus base 2. Okay, then the next section here is 8.5, which is, still continuing with 8.5, but it's kites. So if you remember, properties of kites kites is the only one that has no parallel sides. So no parallel sides. And there were two pairs of congruent sides that intersected. So like this is congruent to this and this to this. And then where the two like non-congruent sides meet, those angles are congruent. So where one, like a double tick mark and a single tick mark meet, and then the double tick mark and the single tick mark meet, those would be congruent. So this would be 75 degrees. And then it's still a still a quadrilateral. So all of these have to add up to 360. So if I add the 75 and the 75, that's 150. Add the 80, that's 230. And then subtract that from 360. And I'd get 130 here. So you can fill in all the sides, all the missing angles. So this time they asked for V, which would have been 75. This case, I would have to add these two together and then subtract it from 360. So 360 minus 164. That's 59. 196. And then divide that by 2 because these would be the congruent angles, and that's where the 98 comes from. In 40, these would be the congruent angles, so this would also be 90 degrees. Add up 90, 90, and 80 and subtract it from the 360, and you get the 100. So then 41, you're not really having to prove from a picture what kind of quadrilateral is, but you would want to know that if it is a specific kind of quadrilateral, what are the properties to it. So if it's in this case, these are just diagonals that are bisected. This is just a parallelogram. So if it's a parallelogram, diagonals are bisected. We went through all these properties. Opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. Consecutive angles are supplementary. If it's something like this, where the diagonals are congruent and bisected, and they're perpendicular, this is going to be a square because this is the overlap of a rectangle and a rhombus. So a square has all the same properties as parallelogram, but it also has 4 congruent sides, 4 right angles, diagonals that are congruent, and diagonals that are perpendicular. All right, there's no coordinate point problems, so you don't have to worry about 8-6.